Substitution to find the integral of the square root of x cubed plus 2x times 3x squared plus 2 with respect to x. So these u substitutions, you're probably used to making u a nasty bit in a square root sign, so a good candidate for u already would be this x cubed plus 2x. A really useful reason why it makes it an even better candidate is because if you think about x cubed plus 2x, when I differentiate that, it differentiates to, it becomes 3x squared plus 2, and 3x squared plus 2 is the other part of the function. So if you're familiar with the way these things work, when you try and rearrange, as in you try and replace the dx with something to do with du, and what you end up with a du, and you also end up with this sort of divisor that tends to be, well, not tends to be, that always is the derivative of the u. So when I make u this x cubed plus 2x, I'm actually going to be able to knock out all of this, so it would probably make a lot more sense once I actually show you it happening. So formal approach, let u equal x cubed plus 2x. So now I'm looking to get an expression for dx in terms of du, so I can then integrate the thing with respect to u. So du by dx equals 3x squared plus 2. So now I'm going to solve to make dx the subject, so I'm going to move it up here. So 3x squared plus 2 dx equals du. So du over 3x squared plus 2 must be dx. So now I'm ready to rewrite the integral, and you're going to see something incredibly useful happens in it, and it turns it into an incredibly easy integral. So now we've done all of this, the integral equals, so the integral of, well, this is the square root of u multiplied by, with 3x squared plus 2 we haven't actually done anything with, so times 3x squared plus 2, and then I'm going to write my dx in terms of du. So dx now we know is du by 3x squared plus 2. Du over 3x squared plus 2. And look at that, it's literally as simple as cancelling the 3x squared plus 2's off, and then you're left with the integral of square root u with respect to u. Du, which is as easy an integral as you could ever hope for now. So I'm going to put it in index form, so equals the integral of u to the half du with respect to u. So the way to integrate a polynomial, you add 1 to the power, divide by the new power, so equals u to the half plus 1, that is 3 over 2. I need to divide by 3 over 2, so I divide by 3 and I times by 2, and I must add the constant of integration. So now we want to get rid of u, put it in terms of x, so u was x cubed plus 2x, so equals 2 times x cubed plus 2x to the power 3 over 2 over 3 plus the constant of integration. Now, this would generally speaking be enough for full marks unless you've been asked to give it in another form. Personally, I don't particularly like looking at fractional powers, so I will try and simplify that. And if you recall that x to the power 3 over 2 is often written as x root x, I can use this to write x cubed plus 2x to the power of 3 over 2 as x cubed plus 2x times root x cubed plus 2x. So equals 2 x cubed plus 2x times root x cubed plus 2x all over 3 plus c. Now, I'm sure there'll be plenty of you thinking, well, that actually doesn't really look a lot nicer, and I do understand that. It's probably quite difficult to defend my position. But if you then had to substitute values in and find things, then I think this would potentially be easier to deal with. Anyway, that's the end of the question.